Energy Control and Lockout Tagout. Section 1. Intro to Lockout Tagout. Welcome to this essential training on Energy Control and Lockout Tagout training, also known as LOCTAG, Clear, and Try training. These terms are interchangeable and refer to essential procedures that control and verify energy hazards are eliminated before maintenance begins. Imagine reducing machinery-related risk to zero. Lockout Tagout makes this possible. By fully isolating equipment from all energy sources, Lockout Tagout creates a zero energy state that allows maintenance to happen without the fear of an unexpected startup. And it's not just a good idea, it's required by OSHA. When we commit to Lockout Tagout, we make maintenance areas safer for everyone. Section 2. Core Concepts of Energy Control. In Lockout Tagout, isolating every energy source is critical to creating a zero energy state. This state means that all potential energy sources, whether electrical, hydraulic, pneumatic, or mechanical, are fully controlled to prevent unexpected hazards during maintenance. Let's look at some essential concepts. Certain systems such as hydraulic or pneumatic may retain stored energy, even after being powered down. To safely release this stored energy, we close all valves and perform a procedure known as bleeding, which eliminates residual risk. We also use blockout techniques to physically prevent machinery or equipment from moving. This could mean placing blocks or barriers on electrical, pneumatic, or mechanical components to ensure no unintended activation. Energy control involves using devices to block power sources from transmitting energy, effectively preventing any unexpected startup or stored energy release during maintenance. This control is achieved through energy-isolating devices like circuit breakers, disconnect switches, or line valves that physically stop the transmission or release of energy. Interlocks are not a replacement for Lockout Tagout. They may add extra protection, but they do not fully isolate energy. Interlocks only prevent operations under specific conditions. They do not lock out hazardous energy. A zero energy state means that all potential sources of energy are isolated, whether they are electrical, hydraulic, pneumatic, or mechanical. Each type of energy requires specific steps to ensure it's fully controlled. For example, for electrical energy, turn off the power at the circuit breaker and apply a lock to the switch. And for mechanical energy, block moving parts to prevent movement, like inserting a lockout bar in a conveyor belt. Section 3. Roles and Responsibilities. Every team member has a role in making Lockout Tagout effective. Authorized team members are those specially trained to perform each Lockout Tagout step, isolating and securing energy sources by applying locks and tags. They ensure that no one else can accidentally reactivate the equipment during maintenance. Affected team members, on the other hand, work near the machinery or equipment, need to recognize lockout tags and avoid locked out equipment to prevent accidental startup. Other team roles include operations managers who ensure lockout and tagout tools are available, department managers who oversee distribution of lockout tagout tools, and environmental health and safety managers who maintain lockout tagout records and inspect compliance. Section 4. When to apply lockout tagout. Lockout tagout applies whenever maintenance or troubleshooting requires disabling a safety device, bypassing guards, or putting any part of the body near moving parts. For example, if you're clearing a jam, adjusting a machine, or conducting repairs that expose you to operational points, Lockout Tagout ensures all potential hazards are controlled. This involves shutting off energy sources and applying a lock and tag to each one. The result is a zero energy state, meaning no stored or live energy is left to pose a risk. Section 5. The Lockout Tagout Process. The Lockout Tagout process is carried out in 5 critical steps. Step 1. Notify. Notify everyone in the area, making sure they understand that maintenance is about to begin and that equipment will be shut down. Step 2. Isolate. Isolate each energy source, which means turning off all electrical circuits, closing valves for hydraulic and pneumatic systems, and blocking mechanical components to prevent any movement. Step 3. Apply. Authorized employees apply locks and tags to each control point, preventing accidental reactivation. Step 4. Clear. Clear the area of any non-essential personnel, ensuring that everyone is safely distanced. And lastly, Step 5. Try. Perform the try step to confirm all energy is isolated and that no stored or live energy remains. During this process, each lockout device, such as a physical lock, is applied to secure energy sources, and a tagout device is attached to indicate that equipment must not be operated until maintenance is complete. Section 6. Past lessons learned. A lack of energy control. A maintenance tech was caught beneath a glass table bridge while troubleshooting belt speeds inside a safety cage. An operator had his finger amputated after reaching behind a guard to clear a jammed piece of vinyl. A lack of energy isolation. An operator had his finger amputated and reattached after pushing a piece of wood through a table saw, without isolating the energy source. Section 7. Restoring machinery to operation. Restoring machinery to operation after maintenance is as carefully controlled as the lockout itself. The authorized team member inspects the area, ensuring all tools are removed, guards are in place, and team members are clear. Controls are checked to confirm they're in a neutral or off position. Only after verifying all safety conditions are locks and tags removed. Section 8. Special scenarios. Lockout-tagout procedures adapt to more complex scenarios, such as group lockouts, contractor work, and shift changes. During a group lockout, each team member applies their personal lock to a group lockbox, ensuring that no one can reactivate the equipment until all locks are removed. Contractors working on equipment must also follow a lockout-tagout under supervision, using company locks or lockboxes as needed. Shift changes require special coordination. Locks remain in place until the incoming authorized team member applies their own lock, maintaining a continuous lockout. Section 9. Training and retraining. Lockout-tagout training gives each team member the tools to perform lockout procedures confidently. Authorized team members are trained to identify every potential energy source, whether it's electrical, hydraulic, pneumatic, or mechanical, and to fully isolate it. This training is reinforced with annual refreshers and further instruction after any incident. Affected team members receive training to recognize lockout tags and understand their role in maintaining a safe perimeter around locked-out equipment. And finally, Section 10. Steps if lockout cannot be completed. If unexpected issues prevent a lockout from being completed, we have a clear protocol to follow. The authorized team member must notify a supervisor, assess which energy sources are isolated, and document any deviations from the standard procedure, including what steps were taken to prevent risks in the interim. Temporary safety measures can be applied, and additional assistance should be requested if needed. If a lock needs to be removed and the original team member is unavailable, an emergency lock removal process is followed. This includes supervisory approval and detailed documentation of every action taken. Let's review. Lockout-tagout is essential for keeping everyone safe during maintenance. Each step, from notifying others, isolating all types of energy, to the final try, works to create a zero energy state. Lockout-tagout isn't just a process, it's a decision to maintain a safer workplace. Thank you for working safe. Please reach out if you have any questions about lockout-tagout's practices or procedures.